Hello everybody. So in this video we're going to talk about radian and degree measure. I assume that you guys already know some things about degrees based on your experience in geometry, so we're going to focus on radian measure. So the first thing we want to do is talk about the parts of an angle. So if we look at just an angle in the plane like this, right? We have to indicate which way the angle opens, so we'll show that it opens this way. Okay, in this case, we would say that this point right here where the two sides of the angle come together is called the vertex of the angle. Okay, so that's this point here. This side where the angle starts is called the initial side, right? Initial meaning starting. Okay. And then this side where the angle ends is called the terminal side, right? Terminal meaning ending. Okay, so those are the three main parts of the angle. And again, you can only determine the initial side and the terminal side if we know which direction the angle opens. Okay, so let's talk about how we normally place an angle in the plane. Okay. Okay, so we're going to place the angle into the Cartesian plane. So the Cartesian plane is just the normal XY grid that you guys use to graph. Okay, so how we're going to place it into the plane is with the vertex at the origin. Okay, and the initial side along the positive x-axis. Okay. So we call that position standard position. Okay. So for example, if we have this Cartesian plane here, we would place the vertex at the origin here. Our initial side would be here along the positive x-axis. It opens whichever direction it opens. The example that we gave over here opened upward. Okay, and then we would have our terminal side here. Okay, so this is an example of an angle in standard position. It is supposed to mirror this example right here. Okay, so let's talk about which direction the angle opens. So we say that counterclockwise rotation okay, which is what you see right here, generates a positive angle. Okay, Now you can see from the example that we have over here, when it opens counterclockwise from the positive x-axis, we can see it as positive opening because it's opening what looks like upward, okay? Whereas clockwise rotation, right, clockwise rotation will look like it's opening down, so we say that this generates a negative angle. Okay, so again, when we look at what it looks like here, it's starting to open up with counterclockwise rotation. That's going to give you a positive angle. If it's starting to open downward like this, that's going to be a negative angle. Okay. Now let's talk about the two ways that we have to measure angles. Now, one way to measure angles you guys are already familiar with, and that's degrees, right? So this is just another way to measure like what size an angle is, okay? But it is not the only way to measure what size an angle is. Just like when we talk about feet, this is one way to measure distance, but you could also use meters, and that's another way to measure distance. We have the same choice when we talk about angle measure. We can use degrees, that's one way to use angle measure, or we could use radians, that's another way to describe angle measure, right? And just like feet and meters, radians and degrees, there's not one that's better than the other. It is really just a difference of what system you're using. Okay, so we would say that okay, here we go. We would say that radians right? So they're just a unit used to measure angles. They're an alternative to degree measure. Okay, so let's go ahead and look at some common angles in radians. Okay, so one of the most common angles that we see and we have already talked about is the right angle. Okay, so when we talk about a right angle, this in degrees is 90 degrees. In radians, this is pi over 2. Okay. We also talked about a flat angle, right? Especially when we talked about supplementary angles. So if we're talking about a flat angle like this, this would be the angle pi. Okay, you can see that pi over 2, two of those would be the angle pi, just like twice 90 degrees is 180 degrees. Okay, if we have one full rotation, right, like start here and circle all the way back around, okay, this we know would be 360 degrees, or in radians it would be 2 pi. Okay. The other angles that we're going to be using a lot are the 45-degree angle, right? We talked about this when we said stuff about the isosceles right triangle. So when we look at a 45-degree angle, which looks like this is going to be pi over 4. We also want to talk about the other two angles in our special triangle. So our 30-degree angle, right, which is a very small angle like this, is going to be pi over 6. Okay. And our 60-degree angle, which is our last angle from our special triangles, okay, that's going to be pi over 3. Okay. So these are our most common angles in radian measure. Just for reference, especially with what we're going to do in our next example, is the angle that starts here and ends down here, right, is going to be 3 pi over 2. Okay? Each 90 degrees or each vertical is pi over 2, so this would be 1 pi over 2, right, or 90 degrees, 2 pi over 2 or pi, right, and then 3 pi over 2, and then 4 pi over 2 or 2 pi, just like we said here. Okay, so here's all of our basic angles in radians. So what I want to do now is look at what the quadrants look like with these angle measures in radians shown on them. Okay, so let's go ahead and we're going to make a basic Cartesian plane here. Oops, that is not what I want. So here's our basic Cartesian plane, and then we're going to label all of these basic angles that we just talked about, right? The 90-degree angle as pi over 2, the flat angle as pi, okay? So this is going to be when it hasn't opened at all, we know that this is 0 degrees. Okay, so this is going to be 0, right? Now, we don't put anything to mark the measure when we talk about radians, so we don't need to put like a degree symbol or anything like that, because 0 is by itself indicates radian measure, okay? This one is pi over 2. Right? This one is pi, and again, we're doing positive angles. We're opening upward, which is counterclockwise rotation. Remember, this one is 3 pi over 2, okay? And then when you get back around, that's 2 pi. Okay, so there's all of the basic angle measures set out there. Okay. So let's go ahead and talk about what it means to, or where in this we're gonna fall if we have different angles. I just want to remind you guys of what the quadrants are labeled as. So remember, this is quadrant 1, this one is quadrant 2, this one is quadrant 3, and this one is quadrant 4. Okay, so we're going to look at an example of deciding where in the quadrants these angles would actually fall, looking at some angles given in radian measure. Okay. Okay, so let's go ahead and start with an angle, pi over 5. Okay, and now what we're going to do is, because it's positive, right, we know it's more than 0, which is the flat line here. So we're going to start, we know it's opening this way, again, because it's positive, and then we're going to compare it to this angle here, or pi over 2, right? If it's greater than pi over 2, we're going to keep rotating around. If it's less than pi over 2, we know that it's between 0 and pi over 2. meaning it falls in the first quadrant. Okay. If you can't tell which quadrant it falls in because you're having a hard time comparing the two, you can always change them to have the same denominator, right? So if we're looking at over 2 and over 5, our common denominator would be 10. So this would be 5 pi over 10. And the angle that we're looking at, right, if we change to common denominators, is 2 pi over 10. Okay? So we can see that our angle, 2 pi over 10, is going to be between 0 and 5 pi over 10, right? Meaning that that angle will fall in the first quadrant. So that would be our answer. It's in quadrant 1. Okay, let's look at another angle. So we're going to look at 7 pi over 4. Okay, and again, if we're having a hard time deciding is it bigger than these angles that I have labeled or not, we're going to look at having common denominators, right? So if we have 2 and 4, that means that our common denominator is going to be 4. So we're looking at this as 2 pi over 4. Now the angle that we're interested in, 7 pi over 4, that's going to be bigger than 2 pi over 4, so that we know it goes past this 90-degree point. Then we're going to look at pi. Well, this is going to be the same as 4 pi over 4. So 7 pi over 4 is bigger than that too, so we're going to keep rotating past that flat angle. What about this? This is going to be the same as 6 pi over 4. So it's bigger than that too. So our angle is opening up past this, past pi, past 3 pi over 2. Is it bigger than 2 pi? Well, this would be 8 pi over 4. So no, it's smaller than that. It's going to be between 6 pi over 4 and 8 pi over 4, somewhere in quadrant 4. Okay, or if we're using Roman numerals, quadrant 4. Okay. All right, let's go ahead and look at one more angle, and we're going to look at a negative angle. Okay, so we're going to look at the angle negative pi over 4. Okay. Now, because this angle is negative, we know that it's going to be opening down, okay? So I actually want to compare these a little bit differently, okay? So it's not going to be, oops, didn't need to erase that. It's not going to be opening the same way that the other angles we looked at were opening, right? They were opening counterclockwise. This angle is going to open clockwise because it's a negative angle. Okay. So if we think about that, this angle is still 0, and then if we're opening counterclockwise, the angle measures are the same, but now they're negative. So we open this way. This first demarcation is going to be negative pi over 2. This one is going to be negative pi, right? And this one is going to be negative 3 pi over 2. Okay, and then we're going to compare to pi over 4. So again, we want to change to have the same denominator so that we can actually compare them, right? So this is going to be negative 2 pi over 4. Okay, and we can already see that our angle is between 0 and negative 2 pi over 4. So it's going to fall into this quadrant that it encounters first, but that's actually quadrant 4, right? Because it's opening down. So when you're talking about negative angles, all of the angles that you're comparing to are also negative. So remember this right angle is always pi over 2. So it's negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2. And if we got all the way back around, this would be negative 2 pi or negative 4 pi over 2. Okay. So, in the next video, we're actually going to talk about drawing angles in standard position and what does it mean for angles to be coterminal. Okay, so I will see you guys then.